AI agents are practically everywhere now. They're helping us write code, crunch data, and automate all sorts of tasks. But as these tools get more and more powerful, there's a huge security question we really need to be asking. So if AI is building our future, who's building the guardrails? Well, for those of us who are security engineers and developers, that's our job. And it all starts with understanding how these AI agents actually talk to the world around them. And that brings us right to the heart of it, the Model Context Protocol, or MCP for short. This is quickly becoming the standard API for AI agents. So if you want to secure this new landscape, you got to know it inside and out. Let's start with the basics. Okay, so think of MCP as a kind of universal language. It's the set of rules that lets an AI model talk to its tools, access files, and, actually do things beyond just spitting out text. It's the bridge between the AI's brain and the rest of the digital world. Now, to secure this new terrain, we first have to learn the language, right? The protocol really boils down to a few core concepts that are absolutely essential to get. So let's break them down, one by one. First up, we have the model. This is the brain of the whole operation, the large language model, or LLM, that's doing all the heavy lifting and the reasoning. We're talking about things like GPT-5 or maybe Claude Sonnet 4. Next up, the tool. Now, if the model is the brain, then you can think of the tool as the hands. It's the actual piece of code or program that the model can use to perform an action, like, running the sumgrep command line interface to go scan a file for vulnerabilities. Then there's the context. This is pretty much the model's entire environment. It includes all the tools it knows about, the files it has access to, everything. It's the world as the AI sees it. And finally, we have the protocol itself. This is basically the rulebook for how everything communicates. MCP uses a standard called JSON RPC 2.0 to send messages back and forth between the AI client and whatever server is providing the tools. So how does this all fit together? Well, it's a pretty simple four-step dance. First, the client, our AI agent, connects to a server. Second, the server says, hey, here are the tools I've got. Third, the model says, awesome, I want to use that one. And fourth, the server runs the tool and sends the result back. Simple, right? But as you'll see, this simplicity is hiding some pretty serious security risks. And that brings us to where things can go wrong. With a lot of new tech, the real dangers often come from what security researcher Clint Gibler calls old bugs in new contexts. We're about to see some very familiar threats, just in a whole new light. All right, let's look at two really subtle but important attacks: tool poisoning and tool shadowing. With tool poisoning, an attacker uses prompt injection in a tool's description to trick the model into misusing it. But with tool shadowing, the attacker registers a malicious tool with the exact same name as a good one, hoping the client picks theirs by mistake. So one corrupts the tool while the other replaces it entirely. Then you've got something called rug pulling. This is your classic bait and switch. You connect to a server that looks totally harmless, you approve its tools, everything seems fine. But later on, the server operator, or maybe a man in the middle, swaps it out for a malicious one. And just like that, your AI agent is taking orders from an attacker. And here's the kicker. Because MCP often runs over HTTP, a whole bunch of classic web vulnerabilities are suddenly back on the table. We're talking path traversal, every kind of injection attack you can think of, SQL, shell, you name it, request smuggling. It's like a greatest hits album of Web 2.0 problems. If it was an issue for web apps a decade ago, it is an issue for MCP servers today. But beyond all these known issues, there's this new frontier capability that researchers are just starting to wrap their heads around. It's called sampling, and it enables one of the most sophisticated attacks we've seen in this space yet. In fact, the sumgrep security researchers who found this literally said, this is an awesome exploit primitive. And that tells you a lot. When security researchers get that excited about an exploit, you know it's a game changer. So here's the crazy part. This sampling feature lets one MCP server ask other connected servers, hey, what tools do you have? A malicious server can abuse this to discover all the legitimate tools and then instantly register its own malicious versions with the exact same names. It can effectively hijack a tool right out from under the user in real time. Okay, I know, that is a lot of scary stuff. But don't worry, we're not just here to point out all the problems. Now we're going to switch gears and walk through the essential playbook for securing your own MCP setups, whether you're building a server or a client application. Let's kick things off with the server side. If you are building a server and exposing tools to an AI agent,
There are a few rules that are totally non-negotiable. First off, consent is king. You need to get explicit user approval for any data access or action, period. Second, validate and sanitize absolutely everything. Never trust input from the model and never trust output from a tool. Third, you've got to rate limit how often tools can be used to prevent denial of service attacks. And finally, and this one's a big one, if you are using HTTP, authentication is not optional. The spec is crystal clear. You must use OAuth 2.1. Of course, security is a two-way street. So, if you're on the other side, building an AI coding assistant or some other MCP client, you've got homework to do too.
First and foremost, treat every single tool description you get from a server as untrusted. That is your number one defense against tool poisoning. Second, always validate file paths to stop traversal attacks in their tracks. Third, and this is crucial, any of these advanced features like sampling need a human in the loop for approval every single time. And finally, be transparent. Always show the user exactly which server is asking for what and why.
So, we'll leave you with this question to think about. The Model Context Protocol is unlocking a new generation of incredibly powerful AI tools. But with all that power comes new responsibilities and brand new threats. As these agents get deeper and deeper into our workflows, making sure our security practices are evolving right alongside them isn't just a good idea, it's an absolute necessity.